This video shows how to draw diagrams to illustrate different situations. So firstly we're going to show a cup of tea. There's a cup of tea and it's resting on a table. It has a weight going downwards. The weight is equal to the mass of the cup and the tea inside multiplied by the acceleration due to gravity. Because the cup is not falling through the table, there's a normal reaction, which we're going to label R. Notice when it says draw a diagram, it doesn't say draw a picture. So we don't have to draw pictures of these situations, they're just diagrams. So in this case, a cup of tea and a conker look more or less the same. There's the conker. It's being held by a light, inextensible string. That means the string cannot stretch and it doesn't weigh anything. So there must be a force that's holding this conker up to oppose the weight, which is the mass times the gravity. So the weight is equal to mass times gravity. Then we've got a car parked at the top of a hill. Here's a hill, and here's the car. It does look like a conker, but don't worry about that. The car has a weight, and there's also a normal reaction. The word normal means at right angles. So the normal reaction is at right angles to the surface on which it's resting. So it's on that surface, the normal reaction is at right angles to it. There's almost certainly one further force acting, and that's friction, which is opposing the motion. So that frictional force opposes motion. It stops. It doesn't stop, but it tries to prevent the car from rolling down the hill. If it was if it wasn't a very steep hill, then the frictional force would be enough. In this case, it's about 35-40 degrees, so that car is doomed.